So basically, guys, is systems of inequality in 2D, 2 dimension. Okay, we have one inequality, two inequality. No, one no. We have two or more inequality, 2, 3, 4, 5. And we learn how we represent the solution for this. The solution obviously is graphical. Entonces, my recommendation is doing always in decimals. I want to explain how. Let's do it first by hand. Suppose que I have known anything, but by hand. Let me see, by hand. Okay, I have my system of equations, no decimals. After we go back to decimals. Okay. Okay, there you go. Okay, suppose que is given the system. The system is y less than or equal 1/2 x plus 2. This is my first inequality. And my second is 3x minus y less than 3. Entonces now the connection in between the inequalities is not explicit another way. You consider it as and. So you need to satisfy this. So it's not explicit, pero es and. When you don't see any conjunction, you default suppose que es and. So you need to find the region que satisfy this inequality and satisfy this inequality. In other words, and means intersection. Suppose that we have one region, we have another region, and the intersection obviously is the common part. When it's and. This is the only possibility? No. Another possibility is or, but this is very, very weird. And or is union, is this and this together. But this is weird. No, never I put this in this switch. Okay? The intersection. Satisfy this and this. Okay. So let's do it. Remember, we are doing the inequality one by one. Okay. The first inequality, you write the related equation, okay, is y equal 1/2 x plus 2. And you are doing the line of this in the plane. Okay, the y in the set, you know, y is equal to mx plus b. B is 2. So y in the set is 2. And its slope is 1/2. Therefore, slope is 1/2. You know that slope is the ratio between wrong and right. Right is 1, wrong is 2. So it's over because it's positive. And 2 here. You get the second point, and we connecting both points. What kind of line we using? Remember, we have two kinds of line: solid line or dotted line. Solid is when they include equal sign. When it's equal sign, it's solid. So this is convention. When it's less than or equal or greater than or equal, the line que separate two semiplane is solid. Si it's less than or greater than, it's dotted line. In this case, solid because it's the first inequality, no? So we are doing this line. You see? Solid line. Okay, now I don't finish with the first one because I need to shape the top of so above or below, and it's less than. Si es less than, es obvio que es below. O sea, less than, convention, less than or equal below. Below what? Below the line. Is greater than or equal or less than or greater than is above. Above the line. Let me see. Wow. Let me see. Okay. Ok. Ok, entonces es below, ¿no? Es below. And below is something like that. Below the line. Include the line. Of course, include the line. And this is the reason it's solid. Actually, this line must be green, no? In order to complete the idea, green, green. Green, green, green. Green line. Okay, this is the first inequality. The solution for the first, only the first. The solution for the second, well, let's do it. Solution for the second is similar, but in this case, the the line is not expressed in the slope in a set form. So you write 3x. No. First of all, remember the methodology I explained the last time. You solve for y. Okay, minus y less than minus 3x plus 3 divided by negative 1 because I want positive y, no negative y. Y positive is greater than. Remember, when you divide by negative number inequality, you reverse the sign. Is 3x minus 3. Now, immediately after that, you convert to equation because equation give me the related line to split the plane into semi-plane, no? And the y-intercept, again, we compare. This is y equal mx plus b. B and negative 3 here, over there, on the y-axis. And it's lower 3. And it's lower 3. It's lower 3. Therefore, wrong and rise. Rise 3 and wrong is 1. So from this point, 3 up. 1, 2, 3, and 1 to the right. We get that point. And we're connecting now this point using the line, but what kind of line? It's obvious it's dotted line because we have no equal in this inequality. Therefore, do not include this boundary. Okay, you see me. After I can see your attendance. Well, to say you are doing now the line. What kind? Dotted line in this case. Okay, connecting this point and this point. Dotted line. Okay. Super. Now it's greater than. Since greater than is you shape the part above the line. And the part above the line is, I'm using another color, is, for example, yellow. Above the line is this. Okay. Okay, so now I need to find what is the intersection between the green part and the yellow part. And it's obvious, let me using another color, gray color, okay, the intersection is this part. Let me try to do my best. The solution is that part, the solution. You shade that part. Any point inside this gray part satisfy both inequalities. Okay, this is clear or confusing? By the way, that point That point is the point. This is curiosity. 2,3. That was 0,3, and that was 0,-3. Okay. Do you understand the idea? Or no? Confusing or no? But don't worry, no, relax. Because this job, we are doing FHC and NICE using Desmos. Because how you write in Desmos? Well, you write in Desmos like that. Look, I want to show you in Desmos now. You write the original inequality, y less than or equal 1/2 x plus 2. And the second you put inside the curly bracket, and Desmos understand very well, not necessarily solve for y, no. Okay, this is an connection. And so you have 3, 4, 5, you separate by this curly bracket, and Desmos understand very well that the intersection is an intersection. And according to the sign, si es equal or not equal, Desmos understand que es dotted line or solid line. Okay, let's see quickly. And we solve in the second example. Everything in this we using Desmos always, because it's crazy by hand and not exactly, no accuracy. We try. Okay, Desmos now. Okay. Do you see them? No. Okay. Let me try to find the folder for this. The folder for this is Inequality in 2 dimensions. Okay. Let's do an example. Do you see this? Yes or no? Answer me.
Yeah, we can see it.
Yes.
Okay. Example 2 is this. Look. Okay. I copy. Look at the way I copy. I copy my first inequality. I copy my second inequality separated by a curly bracket. And the famous point 2,3. Because Desmos sometimes not clear. I suppose that this is solid and this is not solid. Okay, start. Okay. Easy, super easy. Super easy. And we're solving a lot of complicated problems using Desmos. Let's do one more example. Any question? Do you follow me?
Yeah, I'm following.
Okay. Entonces now, next example we are doing I copy in the whiteboard the idea, but I solve it in Desmos, no? Everything so far is Desmos. Look, the second example say, maybe it's linear or non-linear, guys. Example 2 is y less than or equal minus x squared plus 4. Inequality number 1, non-linear, of course, because it's a square. And the second is x minus y, x minus y greater than or equal minus 2. Copy that. This is my system. Immediately I go open Desmos. Let me see, open Desmos. In Desmos, I have here my laptop. I see both inequality. I see. Okay, I open that. Okay, that was example 4. Now example 5. Example 5 is, look, we have the parabola minus x squared plus 4. It's a parabola that open down, and we are linear, x minus y greater than or equal minus 2. Do you see Desmos, right? Help me, guys. Yes or no?
We should.
Okay. Now I put here, and you see the parabola. Suppose curiosity. Suppose que I remove that part. Suppose que I remove that part. Okay, I remove. Entonces, let me select Control C to see. Wow, look at that. This is the parabola, no? And the solution is the area inside the parabola because it's less than. When I copy, paste here, boom, we have a line, just a line, and the line cut off the parabola, no? It's greater than, entonces es only the part que intersecting the solution, okay? Okay, it's clear or not clear? And you have 2 points, que es negative 2,0 and 1,3. This is extra, complementary, not exactly the thing. Now, okay. Let's move into more complicated example. More complicated example. Do you follow me? Everyone follow me or no? More complicated example. Suppose this example. Because I want to copy 4 example. I want to see decimal simulation to see more fast, no? Okay. Share. Okay. Okay. In that moment, I suppose you see whiteboard, correct? Okay. Let's solving. What is the number? Example 1. This is a system, more complicated example. Example 1. Okay, is 3x minus 6y less than or equal to 12. Inequality number 1. 2x minus y greater than 4. Inequality number 2. We have example 2 is 3x plus y less than or equal 6. We have 2x minus y less than or equal negative 1. I have x greater than negative 2. Inequality number 3, and y less than 4, inequality number 4. Wow, in this case, complicated because we have 4 inequalities. So you need to do the sketch one by one and to see the intersection. Example 3 is 2x plus y less than or equal 6. It is similar. Now x plus y greater than 2. Inequality number 2. X is in between 1 and 2. Actually, this is a compound inequality. And this is 3 and 3a. Actually, it's 2 inequality, no? Because this part you consider like a 1 inequality, look. And another part you can consider like another inequality, no? Pero no, es compound, entonces es together. 3 and 3a. And y less than 3. Esa es inequality number 4. Wow, it's look like complicated, but no, it's not complicated when you use a decimal, no? But decimal is fantastic, strong to solving these problems. And inequality number, the example number 4. I have a lot of, let's do it 4. And after you have 1, 2, 3, 4, and 5 more example. And we practice. This is x squared, linear and non-linear, less than or equal to 16. Inequality number 1, and x plus y greater than 2. Inequality number 2. So we have in this case only 2 inequality. And the first example 2 inequality, and the second 4, and the number 3 actually we have 5. In the example 4 we have 2. But we are solving super fast because we open decimals. System of inequalities, the name of this. Okay, switching to decimals. Okay. Do you see decimals or no?
We do.
Yeah, system of inequality. We have several examples, 10 examples. Wow. Look at the first one. The first one is 3x minus 6 less than or equal to 12. And inside the curly bracket, you put 2x minus y greater than 4. Wow. This is the answer. This is the solution. Okay. You see, Professor, it's too easy. Well, it's too easy so far, no? After I want to complicate because this is part of the one big problem. After that, when you learn, you understand very well the solution for inequality. Okay, it's not, suppose that you have no decimals. It's not too hard, but it's, you know, it's no accuracy when you are doing the one piece of paper. Okay, example 2 is, look, it's 3, no, 1, 2, 3, and 4. I copy, look at the way, this is the most important I want you to see, copy. One inequality, the second inequality inside the curly bracket, the third one inside the curly bracket, and the last one inside the curly bracket. And I give you the point, arbitrary point, to understand the boundary, behavior, something. Boom, look at that. Wow. The majority of the scenarios of the inequality look like polygons. No, not always, but sometimes. It's a polygon different. This is a line. In this case, we have 1, 2, 3, and 4 inequalities, but every inequality are linear. So now the boundary encloses the polygon frequently when it's linear. When it's non-linear, no, of course. Okay, let's move on to number 3. Do you follow me? What is the way you put in decimals? If you want, when I send the video for this lecture, I send the link connected with this decimals script, and you can work if you want, no? You open, don't hesitate to change something, because when I send the link, you work it in your cloud, not in my cloud. Okay, example number 3. Example number 3 is complicated because we have 1, 2, 3. Okay, look at that. Look. I separate each inequality one by one by curly bracket. In this case, I can work in this together. And when you do the graph of this, ooh, in this case, how many sides? 1, 2, 3, 4, and 5. It's a pentagon. And this is important, super important, the corner of this polygon, the corner. For some reason, can you understand after that? It's important, the corner. Okay, this is the solution. Solution of this complicated system of inequality is any point inside this polygon. Okay, by the way, I put in the black color, but I can change the color if you want. I like so much black, no? But if you put red, blue, the color you prefer. Okay, now number 4, no? We did number 4. Number 4. Number 4 is this one. Okay, is x squared plus y squared less than or equal to 16. There's only 2 inequalities, one non-linear and one linear. Okay, let's do it. Oh, it's a circle. It's a circle. It's a circle. Look, 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 look. Let me delete temporarily the second inequality. Okay, control, I put in my keyboard, control X. It's a circle. It's a circle where the center is located in the origin, 0,0, and the radius is 4. Now together with the linear is a line, control B is this piece of solution. Everyone follow me, guys? Yes or no? Everyone follow? Yes, okay. It's important, of course, it's important that you practice, you know, but okay, I send the link. You can modify if you want here in your computer or laptop the number. This doesn't affect my work. And you take this like a, you know, the basic to create your new example. Okay, number 5, 6, 7. Let's do it until number 8. Okay, let's move on again to the whiteboard. Whiteboard. And whiteboard we have. Okay, sorry. Okay. Do you see whiteboard? I want to copy. I want to copy 5, 6, 7, 8, 9, and 10. 16. Suppose example 5 is x minus 1 squared plus y plus 1 squared less than 25. Wow, this looks like circle. A circle where the center is located at the point 1, negative 1. That's a circle where the center is located at the point 1, negative 1, and radius is 5. Okay, it's square root 25. And we have another circle, x minus 1 squared plus y plus 1 squared. Wow, it's the same center, but the radius is 16. So it basically is inside. This is inside the circle with the radius 5, and this is outside another circle with the radius 4. No, this is radius 4. How do you believe it look like this region? How do you believe? It's the same center as two circles, radius 5, same center que es this point, another center que es another circle, sorry, que es 4, radius 4, suppose this. Entonces, inside this y outside that, I suppose que the region look like that. Like a ring, no? Make sense or no? Remember, ring. Example 5. Example 6. Is x squared plus y squared less than 16. This is a circle, but it's inside the circle. The center in this case is the origin, 0,0, and the radius is 4. And this is exponential function, less than 2x. Wow, it's weird. Inequality number 1, inequality number 2. This is the number 6 example. Number 7 example is another circle, x squared plus y squared less than or equal 1 is inside the circle with the radius 1 in this case. Radius 1. And the center is the same, 0,0, center. And we have a parabola, y minus x squared greater than 0. This is a parabola. Okay, by the way, this parabola open, let me see in what direction open, let me see. So you solve for y here, y greater than x squared. It's a parabola. So this line represents the parabola when it's equal. But greater than it says above. It's supposed that the region will look like that. Above. Okay, but this is curiosity. Desmos figure it out that idea. Number 1, number 2. Number 8 is also parabola. Example 8 is y greater than x squared y. It's the same. Inequality number 1 and y equal 4 minus x squared. Inequality number 2. Wow, it's the same. So this is this and this no. This is different because it's a parabola that open down because x is negative and the y is 4. So our second is, I suppose then que the solution is that part. Okay, but just in case we check in decimals. Number 9 is complicated. Is 0 less than or equal y less than or equal to. This is compound inequality. Actually, it's 1 and 1 and 8. X greater than or equal to 0 is number 2. Y greater than or equal to 0 is number 3. And x less than or equal to is number 4. Wow. It's linear, so it's easy to see. Okay, look, let me try by hand. This is my rectangular coordinate system. The first inequality is y in between 0 and 2. 0 is this. Let me use in Greek color. 0 is exactly y equals 0. And y equal to is 1, 2 here. So in between this and this is this part. This is the representation and independent of x. Only of the first inequality. This one. X and y positive. Let me see representation this. This and this together is the first quadrant. This and this together is the first quadrant. So this and this together is, let me use another color. It's the first quadrant. Is this and this together is the first quadrant. When x is positive and y is positive, both. This only happened in the first quadrant. So now, so far, under the consideration 1, 2, and 3 is this part. Now, the last one, I'm using another color, is this. Is when the x is 2 and less than 2 is a vertical line in 2, 1, 2. Look. This is x equal to, and less than 2 is in the other direction, no, to the left. Entonces, what is the intersection between the four conditions? I suppose que this square. Any point, close it, and close it. For this four inequality is any point in our famous, suppose this point solution, this point solution, this point solution, this point solution. Include the boundary, yeah, include the boundary. Solution, 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 and solution. But let's check in this one, just in case. And the last one, number 10. Number 10 is x greater than or equal to 0, y greater than or equal to 0, x plus y less than 4, and 6x plus 2y less than 12. Inequality 1, inequality 2, inequality 3, inequality 4. 4 inequality. This is a 60. Okay, let me try to do my best by hand. Pero no, horrible. Okay, first of all, this inequality and this inequality together, this inequality and this inequality together is the first quadrant. So our region so far is this. No point in the second, and the third, and the fourth. This is a solution. Consider 1 and 2 only. Now, let's move on to the number 3, que es x plus y less than or equal 4. You solve for y less than or equal minus x plus 4. You are doing the line, and the related line is y equal negative x plus 4. 4 is the y in a set. I suppose here 1, 2, 3, 4, and as low as negative 1, it's going down 1 unit, 1, 1 here. It's obvious que es solid line. And you shape, I suppose, below, no? Because it's less than. So far, consider 1, 2, and 3. The solution is this triangle. So far. Okay, now consider number 4. Let me using another color, blue color. Number 4, blue. You take, for example, 6x plus 2y less than or equal 12. You solve for y, 2y less than or equal minus 6x plus 2. Divided by 2 by 2 by 2. Y alone is less than or equal minus 3x plus 6. And the y is about the 6 here. This is 4. Remember, this point was 0.4. Now 5, 6. This point is 0.6. And as low as negative 3. So 3 down, 1, 2, 3, and 1 up. And this is my second line. E again is below. So now using the blue color, I suppose that the below this line and the green part is this. Let me use another more interesting color. Gray is good. Gray is good. Okay. I suppose it's this solution. Okay. This is my solution. By the way, you can determine the point, the corner, this corner, and this corner. This corner is 1,3. This is easy to determine because you consider like equation, this 3 and 4, and you apply the system and you find the intersection. No big deal. This is 2,0. This is 0,0, of course, and this is 0,4. And thus in this case, we have a quadrilateral, 1, 2, 3, 4 sides. It's a polygon, of course, the 4 sides. And this is my solution. So now I want to show you guys the Desmos, and after you can see the application of this. What is the application in the real life of this? Okay, let's move on to Desmos. Okay, do you see Desmos? Let's see example 5. You remember the example 5? Example 5 is 2 circles. You see the ring? For example, to understand more clear, you have to, suppose que I copy that. Control X. It's a circle. This is the point. The solution for the first inequality is the point inside the circle. By the way, the circle, the center is located at the point 1, -1, and the radius 5. When you intersect both, we have another circle with the same center but a radius 4. but the sign is switching to greater than, to say the ring. Is it clear? Wow, fantastic. Okay, now number 6. This is number 6, no? Oh, number 6 is the circle and the exponential. Let me show you the exponential. I remove the exponential temporary. See the circle, and the exponential is below the exponential, no? Control B, because it's less than. Okay, fantastic. Now, number 7, I remember, is a circle and a parabola. Circle and parabola. Oh, let me remove the parabola. Control X, the circle. We have parabola. We have parabola. By the way, the parabola open. Let me see what direction open the parabola. Open up. So it's inside the parabola and inside the circle. Inside the parabola because it's greater than. And inside circle. Number 8 is parabola, 2 parabola. Look, 2 parabola. Wow. One parabola open up and another parabola open down. Let me select the parabola que open down. I know que open down because the term can contain x squared negative. You know that. Parabola open up. And the point solution is above the parabola, is greater than. However, they introduce another inequality que another parabola but open down. Okay, entonces the solution point is the point inside. It's above the first and below the second. Okay, the last example. Oh, it's the famous square. Do you remember that? Look at that. Wow. It's a famous square. All right, let's do it step by step. Let me remove, for example, this. No, this, only this. Look. Okay, now include everything. One by one. This is, remove this. Oh, it's the strip in between 0 and 2y. Select this. It's only for x positive. Now I'm bounded by 2, 0 and 2. It's a square. Okay, this system can contain 4 inequality. The solution is a square. And the last example, que es number 10, is complicated because let's do it step by step. Let's do it x equals 0, y equals 0. Only that. It's the first quadrant. Oh, it's the first quadrant. Now, little by little, I remove the last inequality. You see a triangle. Do you remember the triangle? And finally, I put the last inequality. And this is the quadrilateral. And this is important, the corner inside 0,4, 1,3, 2,0, and 0,0. Do you understand or no? Let me come back to whiteboard. Guys, do you follow me? I am doing too fast. Eh? Tell me, answer me. Is okay? Everything okay or no?
Yeah, everything's fine.
Everything fine. Okay, now I say you now. I want to show you application of this. Okay, one fantastic application is call it linear programming. Look, linear programming. Okay, let me put it the title here. Linear programming. Period. Okay, what is the idea behind linear programming? We have one problem of the optimization. Optimization. What means optimization in mathematics? Optimization in mathematics is try to discover the best option. And then we have here, let me show you how I explain this. We have several constraints. So we have a system. Okay, you have number one. You have objective function. Objective function is the function that you want to optimize. Optimize means minimize or maximize, depends if it's good or it's bad. Si it's good, si it's profit, for example, you want to maximize. And si it's cost, it's bad, you need to minimize. Normally, the objective function, I don't know why, is symbolized using Z letter. Capital C is a function, x comma y. Okay, this is the objective function. That's the first step. The second piece of the linear programming problem is the system of inequality defining the constraints. It's the constraints. Constraints on x and y. So we have one function. And otherwise, we have additional. Furthermore, we have constraint. Constraint is several. It's a system of inequality. I don't know. Suppose x plus y greater than or equal 10, x minus 2y less than or equal 6, and several. This is a constraint. Entonces now, how you solving the problem of the linear programming? Remember, the linear programming is optimize, optimum. Number 3, you graph the feasible region. Feasible region. What is the feasible region? Feasible region is the solution for this system. Suppose that the solution for this system represents one polygon like that. Normally, in linear programming problem, the feasible region is the polygon. And you identify the corner of the vertex. You identify this corner, this corner, this corner, this corner, and this corner. You identify 1 comma something, 2 comma something, so the point, the value of this corner, the order pair can represent this. And number 4 is the last step. You evaluate the objective function C in every corner. And at each vertex, and finally you find the maximum or the minimum you want, because the objective function normally is linear. So that is the reason it's linear, but everything is linear. Nobody is non-linear. In the linear programming problems, the objective function is linear, and the constraints is also linear. That is the reason que es no circle, parábola, no. It's just a polygon. And the objective function, for example, is this line. Que is this line for one value of the C. Suppose C equal 100. C equal 100. But this is completely outside the feasible region. That means it doesn't work. And you approach a little bit, approach it until you touch one corner. And this is the optimization. Si you continue decreasing, suppose that you get this and C equal 20.5. This is maybe the maximum. So you continue decreasing. It's also inside the feasible region, but it's not the maximum or the minimum, depending on the problem. You see several problems. Guess the good thing is the minimize, and the good thing is maximize. So linear programming. Let me summarize quickly and don't frustrate because it's too easy. And we're using decimals again, one more time. Is application of this. Now, in the application, you have several constraints that define one feasible region in 2 dimensions, and we have one objective function. You are doing the graph of the inequality, exactly the same we are doing before. You obtain the feasible region, and you evaluate the objective function one by one in each corner, and you take the maximum or the minimum depending the thing you want. You want to optimize or minimize. Okay, so now suppose you have a lot of questions, no? Obviously. Let me try to see at least one problem. Okay. Let me see at least one problem. Okay. Suppose the first problem. Easy. Now, hypothetically, linear programmer, hypothetical, theoretical, when you master the way to solving the problem of the linear, so we go to the applications, in which I give you one company, need, minimize the profit, something, but so far it's theoretical, today at least. Suppose example number 1 of linear programming. Example number 1. You need to, okay, you have the constraint, this is x greater than or equal to 0, inequality number 1, y greater than or equal to 0, inequality number 2, x plus y less than or equal to 60, inequality number 3, and y greater than or equal to 2x, inequality number 4. Okay, this is the collection of the inequality that represent the constraints. Constraints is when our problem have sense, physical sense, logical sense. However, we have another hand, the objective function, z, capital Z, que es 250 x plus 150 y. And my goal is maximize, maximum, find maximum m, maximum value of this function, of course, inside this constraint. This is the idea. Okay, let's do it. Now I prepare another script of Desmos. This is graphically, everything is graphically. Okay, here you go. Linear programming. Boom. Okay, there you go. Do you see Desmos? Yes or no? Look, this is the way. Okay, I want to explain. This is the way. Okay, I recommend you that you are doing in decimals. First of all, you copy one by one the inequality in order to determine the feasible regions. Look, let me show you here. Bam. No. Okay, one by one. First, only one. Okay, and no necessary level. Okay, you copy that. Boom. Oh, this will look like a triangle. Okay, the corner in this problem is, look, 3 point. It's a triangle, 2 vertex. The label associated with this is 0,60, 20,40, and 0,0. So now I recommend you, can you take the objective functions, que es 250x plus 150y, and you solve for y. Entonces y alone is equal a, I call a or c, either way, doesn't matter. And you create a slider to change the a value que actually is c. So the thing I want to find is c. But in this moment, I can do like that, or no necessarily like that. You put in the piece of paper, it's doing. I determine the feasible region, got it. The corner, 0,0, 20,40, and 0,60. I'm plugging in this value into the function. Okay. However, I would like to show you one thing. This is a line. Yeah, I change the line. Look. I change the line. Actually, I put 12,000 here. But I can change. Click here and not 12,000, no 40,000. 40,000, I don't know, si it's dollar, I don't know. So you change, this is a C value, look. This is completely out the feasible region. This is completely inside the feasible region. However, what is the maximum value? Oh, the maximum value is the value in which touch this corner. Okay, by the way, is 11,000. And this is the maximum. Okay, satisfy both conditions. Satisfy the objective function and is inside the feasible region. Okay, let me come back to the whiteboard to illustrate one thing, not necessarily doing in this way by hand. So when you determine, okay, sorry, when you determine, no, here, over there. When you determine, do you see whiteboard? So the complicated part, the most complicated part is the solution of this inequality, no? You know, but we have no problem with doing that because we use decimal, no? But I discovered que it look like triangle like that. And this corner is 0,0. This corner is 20,40. And this corner is 0,60. And this is our feasible region. Now you don't need to do the line of the, no. You take the objective function, C, and you evaluate in each corner. 0,0 is the first one, 20,40 is the second, and 0,60 is the third one. And you evaluate. This is 250 times 0 plus 150 times 0. It's all because 0. 250 times 20 plus 150 times 40. I'm putting a calculator and the answer is 11,000. Wow, it's exactly the same, the value can I get. However, to make sure that this is the maximum or no, I plug it in the other corner, que es 0,60, is 2 times, or 250, sorry, times 0 plus 150 times 60. And the answer is 9,000. So in conclusion, the objective function here, the value for the C at that point is 0. The value for C here is 11,000. And the value for this is 9,000. It's obvious that this is the final answer of this problem is the C maximum is equal to 11,000 at the point x equal 20 and y equal 40. Okay, I don't know exactly what is this or this. You see in the word problem, who is x, who is y? Actually, now it's algebra, x and y. And when the word problem, you get some meaning. Okay, maybe it's, you know, dollar, or I don't know. Any question? Do you understand very well or confusing? Come on. Opinion. Open the microphone or the chat.
So we get the 20 and 40 from decimals.
Good question. This is a good question, mister. How you get that? Good question. Well, this line, good question. This line is this line. So this line is y equal to x. And this line is x plus y equals 60. And you form a system of equation exactly the same we are doing before. For example, substitution may be instead of y equal to x, you replace here x plus 2x equals 60. This is 3x equals 60 divided by 3. X is 20. And plugging in here, y is 2 times 20 is 40. Got it? O sea, it's relatively easy determine that point because it's the intersection between this line and this line. Well, this point is 0, 0. And this is the, okay, this line, is this line. We have to intersect, is 0,60, and this is 60,0. But this is completely out the feasible region. More clear now?
Thank you.
Pleasure. Let's do the second problem. And that's it for today. Linear programming, guys, remember. Next time, we are doing application in the word problem. No, we have more sense to talk about this. Who is X? Who is Y? It's a I don't know, it's a truck, it's a tree, it's a movie. Okay. Suppose example 2 now. Example 2, say. X greater than or equal to 0, y greater than or equal to 0, 2x plus y less than or equal to 8, and x plus y greater than or equal to 4. Actually, we have 1, 2, 3, and 4 inequality. This is system of inequality. We're solving exactly the same we learned before. Represent the constraints of the our problem, limitation, no? And we have objective function always, z equal 3x plus 2y. I need to find in the example 2, let me see. We need to find the maximum, yeah, the maximum. So we need to maximize find the maximum. Maximize ¿Verdad? It's okay. This is spelling maximizes C. In other words, find the maximum value of C inside this feasible region. It's a technical name, feasible region. It's a region bounded by this. Okay. The hard part is the inequality part, as always. But for solving this problem, we have decimals. Right? Okay, let's do it. Okay. I suppose you see this one, yes or no?
We see it.
Okay, example 2. Look, let's do it first of all. Only the feasible region. Look, let me show you. Make a zoom to see more clear. This is the solution for the inequality. And represent again triangle, yeah. And the corner are, let me make a zoom to see more clear. Sometimes one corner is, no, it's okay. Let me see, it's okay now. Okay, the level of the corner is 0,8, 0,4, and 4,0. And you take the objective function, solve for y. Entonces en décimo I call no C, I call A, A1, A2, A3, A4 in any example. And you see this. Look, let me show you. Okay, this is C value. You see, entonces in your opinion, remember the maximum, the optimum is the first point in which the objective function touch the feasible region. Que es obvio que here. Bam. Okay, entonces you see here the answer 16. 16 is the answer. At what point? At 0,8. So es máximo when x is 0, y is 8, and z is 16. Another point, no maximum. No maximum. Another point is outside. Entonces es bigger, it's 21. However, don't belong to the feasible region. Entonces this is the problem, no? I need to find the thing that have sense according to my word problem is only inside the feasible region. Outside, it's stupid. Now, the first time that my objective function touch the feasible region is here, in that corner, in the corner 0,8, and the answer is 16. Let's come back to the whiteboard to see the effect. Okay. Okay, suppose you see again whiteboard, no? So now the complicated part was determine the feasible region. I get something like that. I take 1 point here, que es 0,8. I take 1 point here, que es 0,4. Y I take 1 point here, que es 4,0. Okay, one line here. Always this line. That is the reason que es linear. And my feasible region is this. Okay? And you evaluate as Z equal 0,4, as Z equal 4,0, y as Z equal 0,8. Okay, let's do it. Entonces, 3, this is X value, this is Y value, 3 times 0 plus 2 times 4. Sorry. 2. Here, you replace x equals 0, y equals 4. Es obvio que es 8, ¿no? Es 8. 0,4 es 3 times 4 plus 2 times 0. Es obvio que es 12. Ajá. Es 12, yeah. And finally, 3 times 0 plus 8 times 8. 8, no, 2 times 8, sorry. 2 times 8 is 16. And this is the maximum value. See, maximum is 16. No always is maximum. Máximo o mínimo. Depending the problems. Si es mínimo, entonces another thing. I need to find the minimum. The minimum, the answer is this. Is the minimum. But in this case, maximize the problem. Entonces es, the maximum is 16 at x equals 0 and y 8. End of story. You understand or no? Super clear? Very well, very well, very bad. Next time, I promise, I will send the review back, guys. Stop sharing. Okay. Now you see my face?
Yes.
Okay. No question?
So the answer for the previous question was 16, correct?
Yeah, but no like that. Completely the answer is the maximum value is 16 at x equals 0 or y equals 8. It's important the point when it's maximum.
Okay, thank you.
Okay. Bueno, guys, bye-bye. Have a nice good day.
Have a good day, Professor.
Okay.